Mean versus median. So when discussing these two measurements of center, what you have to realize is a few things. First, the mean is what's called sensitive to outliers. And the reason why those extreme data points will skew the average overall, where the median is what's called resistant to outliers. And again, the reason why for this one is because it's a placeholder overall. So median is positionality, and an outlier will not necessarily change the position, but the mean takes into account all variables, hence it will change the overall mean when you have an outlier overall. And furthermore, typically you'll report the mean when you have symmetric or normal distributions. So when it's symmetric or bell-shaped, that's the best time you would report it. The median is reported when it's a skewed distribution. Speaking of symmetric and skewed, three common shapes you should be familiar with is you have your bell-shaped, mound-shaped normal distribution here in the middle. On the left, I have skewed to the left. Remember, skew is the tail. And on the right, I have skewed to the right. Remember, skew means tail. Now, in addition to knowing these different shapes, again, that's skewed left, also known as left skewed, symmetric, bell-shaped, mound-shaped, normal, and skewed to the right. You also need to know where the mean might be in relation to the median. So if you recall, the three measurements of center are mean, median, and mode. So what I'd recommend doing is writing the words mean and median below each one of these. You'd have mean median, and mean median, like so. Now, when the distribution is bell-shaped, mound-shaped, symmetric, normal, we would expect the mean and the median to be about the same. When it's skewed to the left, you would draw an arrow pointing to the left, which signifies the mean is less than the median. And when it's skewed to the right, you draw an arrow pointing to the right, which signifies the mean would be greater than the median. And this is typically what happens in these types of distributions. For example, if I was to give you two different sets of data, let's say you had 2, 4, 6, 8, and 10. First is 2, 4, 6, 8, and 1,000. And let's talk about the mean versus the median here. So the mean, if you recall, you would add up everything and divide by the count. So 2 plus 4 plus 6 plus 8 plus 10 divided by the sample size of 5 will give you a mean of 6. The median is the middle number. And with a list of 5 in order, you can see the median is 6. However, if you have 2, 4, 6, 8, 1,000, adding all those together will give you 1,020. Divide that by 5, and that'll give you 204. But the median, the middle number, is still 6. And so what this is trying to show is up here in the very beginning, the mean is very sensitive to an outlier. 1,000 is an outlier in comparison to the rest of the numbers here. So therefore, the mean severely shifted from 6 to 204. However, the median is resistant, which is why it stayed 6. Lastly, 2, 4, 6, 8, 10 is very regimented. It's very symmetric. So it's no surprise the mean and the median were equal to each other here. For 2, 4, 6, 8, 1,000, you could consider this skewed to the right because all the data is clumped together on the left, 2, 4, 6, 8, and it skews off to the right. Because if I draw an arrow from mean to median pointed to the right, I can see the mean is greater than the median. Lastly, since it is skewed, I would report the median. 6 is a better indicator of 2, 4, 6, 8, 1,000. I would not say the average of these overall is going to be 204. Even though that's technically correct, that's not the best report for skewed data. And for symmetric, while it doesn't matter, you'll see that the mean will be reported for symmetric data.